हेलो फ्रेंड्स, वेलकम टू मोल-मेंटम। आज हम बात करेंगे कि क्लास 12th इलेक्ट्रोकेमिस्ट्री चैप्टर में कैसे हम किसी सेल रिप्रेजेंटेशन मींस किसी सेल रिएक्शन को लिखते हैं और फिर उससे कैसे ईएमएफ कैलकुलेट करते हैं। तो सबसे पहली चीज जो हमें याद रखना है कि वी ऑलवेज हैव टू राइट रिडक्शन पोटेंशियल। दैट मींस रिडक्शन पोटेंशियल इज द स्टैंडर्ड पोटेंशियल। दैट्स इट, स्टैंडर्ड पोटेंशियल। All now reduction means again one thing that you can remember is loss of electrons is called oxidation, which we can represent with the trick also. Leo is a zodiac sign where we can say loss of electron is oxidation. So Leo. Second part is gain of electron is called reduction. Okay. So if I write any reaction, if I write a reaction like any reaction, general reaction of the type M, any metal M, when it gives electron, it becomes Mn plus and it releases an electron. So this process is called oxidation. Why oxidation? Because it is losing electron. At the same time, if I write any other element which is having +1 charge and accepting 1 electron, and it is becoming a solid. Is it clear? So now there is a gain of electron, so we call it as reduction. Simple. Now the thing that you should know is हाउ टू राइट अ सेल, दैट इज वेरी इंपॉर्टेंट. ओके, तो इसके लिए सबसे पहले हम एक कोई भी सेल ले लेते हैं. जैसे इफ आई राइट द एग्जांपल ऑफ डैनियल सेल, डैनियल सेल very famous cell where we have two electrodes, zinc and copper. Okay, so if I write, look at the cell representation. If I write E Zn to Zn2 plus and E naught means EMF, and if I write Zn2 plus to Zn. So the thing is, what is the fundamental difference between these two? Here we can see in first case, these oxidation state of zinc is 0. So from 0 it is going to +2. That means it is losing electron. So this representation is called oxidation potential. Yeah, oxidation EMF. Okay, and whereas this one, zinc is getting reduced from +2 to 0. So this one is called reduction potential. Okay, so the thing is, now what you have to keep in mind is you always have to use this. So this one is going to be the standard potential. Why? Because reduction potential is always the standard potential. Is it clear? Okay, so next is, if I write next, I will take any random cell where you can calculate the EMF of the cell. Okay, so basically this is the way. If you have to write any representation, so you can write Mn plus to M. Why? Because it should come from higher state to lower state, then only it is called reduction. And this is the correct representation. Only this representation is allowed. You will take this representation in exam. Okay, next is if I take any example, suppose NCERT question number 5 says you have to calculate EMF by applying Nernst equation. Nernst equation. So what is Nernst equation? We know that Nernst equation is E cell is equals to E naught cell minus 0.0591 by 2. Then in log we have concentration of product, then concentration of reactant. So this is the Nernst equation to calculate EMF of any cell. So suppose I take any example where we can apply this equation. So I'm taking the first question where Mg in solid state 2 plus and its concentration is 0.001 molar. Then we have copper 2 plus, its concentration is 0.0001 molar and in contact with copper solid. So for this we have to calculate the EMF. So the very first thing is we should write the cell reaction. So how to write a cell reaction? Now look at the EMF that is given. So I should write the EMF first. EMF which is given is E naught shell, E naught of Mg2 plus Mg is equals to minus 2.37 volt, and EMF for CO2 plus is given plus 0.34 volt. So now here is the click. So just by looking at this value of EMF, we can predict which one is anode, which one is cathode. How we can predict? Let us see. Okay, so if I write it, so again what we have here, from higher to lower, that means reduction potential is given. So this one is also reduction potential, and again from +2 to 0, so that means this one is also reduction potential. So both of them are reduction potential, whereas this value 0.34 is positive and this value is negative. That means if the reduction potential value is positive and negative, what does it mean? That means magnesium is having negative reduction potential. That means less tendency for reduction. Why? Because it is having negative potential, and since this is having positive potential, that means higher tendency for reduction. Okay, and we know from galvanic equation that this is the trick, LOAN, lone. What does it mean? Left, then oxidation, then we have anode, and then negative. That means in a galvanic cell on the left side, so this is the galvanic cell which is having 2 electrodes. So these two are connected by some wire. So this is the left chamber, this one is the right chamber. That means in left chamber it is going to be left hand side, oxidation will occur, anode is this side, and this one is negative terminal, lone. Similarly you can write for reduction part also. So since this is right side, so here reduction will happen, and this one is called cathode, and this is positive terminal. Okay, positive. All right, so when we have these two values, this copper is having higher tendency to get reduced. So on which side reduction is happening? This is the side of reduction. That means copper is going to be right side, whereas another one we have magnesium is going to be on left side. So how do we calculate E cell? E naught of cell is written by ER minus E left. So ER we have 0. Plus 0.34 minus, and this value is negative, so this is going to be 2.37, which is equals to 2.71 volts. That means this is the E naught cell for this question. Okay, so if I write the cell reaction now, since you have identified that magnesium is having lower ERP, low standard reduction potential. Why? Because it is negative value. So magnesium is, if it is having low tendency to get reduced, that means this will undergo oxidation, whereas copper having high standard reduction potential, that means here reduction will happen. So for these two we can write half cell reactions for both of them. How? For magnesium we can write magnesium will give 2 electron because it is undergoing oxidation, and copper will accept, since copper is in +2, so copper will accept these 2 electron and get reduced. Okay, so this is copper solid. Okay, for these we have different concentration which are given. All right, so we can write overall reaction. Overall reaction we can write it as Mg plus CO2 plus, this will give out Mg2 plus CO. Okay, so again we know that whenever any solid and liquid are in contact, so solid concentration is taken as unity. So now we will directly apply Nernst equation, because we know we have calculated the value of E cell. So we have calculated E naught cell. What is the value of E naught cell? 2.71. So this is going to be 2.71 minus 0.059 by, what is the value of N? Since number of electrons which are being transferred are 2, so N is going to be 2. All right, so I will divide it by 2, then log. In product what we have? In product we have copper, in reactant in product we have magnesium, in reactant we have copper. So at the place of this we will write Mg2 plus, and reactant we will write Cu2 plus. Okay, so this is 2.71 minus 0.059 by 2, and Mg concentration is given. The concentration of Mg is 0.001. That means this can be written as 10 to the power minus 3, and since it is 0.001, so it can be written as 10 to the power minus 4. So I will write these two values here. So this will be log 10 to the power minus 3, and this can be written as log 10 to the power minus 4. Okay, so this is going to be 2.71 minus, so if we calculate this number, it will become 0.059 by 2 log, and this is 10 to the power minus 4, it will go in the numerator, so it will become 10 to the power plus 4. So basically this is log 10. Okay, log 10 is 1, so this will be 2.71 minus 0.0. So the answer will be roughly around, we will get the answer 2.68 volt. So this is the correct answer. Okay, but the thing that you should know is, first look at the representation. Representation should be like this only, means from higher oxidation state to lower, from n plus to 0. This is called standard reduction potential. So every value has to be written in this way. Second thing, if standard reduction potential is positive, that means high tendency to get reduced. So this is going to be on a right side, that means it is going to be cathode. If standard reduction potential is negative, that means less tendency to get reduced, that means it will undergo oxidation, and when it undergoes oxidation, that means it is a anode. So in this way, just by looking at the value of standard reduction potential, you can guess whether it is going to be on right side or left side. So if I take one more example, like if I tell you the E naught of Fe2 plus and Fe is equals to minus 0.44 volt, and E naught of, again if I write the same example, Cu2 plus to Cu is plus 0.34 volt. So can you tell me which one is the cathode, which one is the anode? Again, first thing you have to check is whether it is SRP, standard reduction potential, or not. So yes, it is from plus 2 to 0, plus 2 to 0. That means both of them are what? SRP, standard reduction potential. Now this value is positive, that means high tendency to get reduced, and this value is negative, that means less tendency to get reduced, that means more tendency for oxidation. So this one is going to be your anode. Why? Because anode is on left side and here oxidation occurs, and this is having higher tendency to get reduced, that means this one is going to be your right electrode, and obviously cathode. Okay, thank you, all the best.